Hey guys, and even though we're not in class, and even though I don't think I'll give you a problem on your homework over a problem like this, we've talked about it so many times, and I was excited just seeing the picture, because I know I've talked to you guys about it before, that I feel like I had to do a video just so you guys can see it. So we're back to our vertical motion model that we all love so much. We've talked about cats leaping in the air, and dropping paintbrushes off ladders, and armadillos leaping in the air. All that fun stuff, but today we're going to talk about the blimp problem dropping ping pong balls. So once again, that is our vertical motion model, where t is a time in seconds the object has been in the air, v is the initial velocity, and s is the initial height that we drop the object at. So if I read this problem, it says, during an ice hockey game, a remote control blimp flies above the crowd and drops a numbered table tennis ball. The number on the ball corresponds to a prize. Use the information in the diagram to find the amount of time that the ball is in the air. So if you look at the diagram, it shows that the blimp is 45 feet above the air. And it also shows that when the person catches the ping pong ball dropped by that wildcat blimp, that he is 17 feet above the ground when it is caught. So if I go ahead and write this out, I have my equation, my formula. It says h equals negative 16t squared plus 0t plus s. You heard that my wife just texted me. She's wondering why I'm talking to myself at midnight, but you gotta do what you gotta do. All right, now that we have that, we have to plug in our information. And if we scroll up real quick, remember that, oh, don't want to do that. If I go up, h is the height of the projectile, and that's its resting spot. So we're going to start with, when we catch the ball, it is going to be 17 feet above the air. So this means 17 equals negative 16 t squared. The velocity, we did not drop this, we did not throw this ball down, it was not propelled down, it was not shot down, it was just dropped using gravity. So there is no velocity, so it would be 0t. And our s, the initial height at which the ball was dropped, was 45 feet in the air. Now, if I want to rewrite this, I can make this look a lot easier by getting rid of that 0t, because I don't need that. So I'll be left with 17 equals negative 16t squared plus 45. This should now look familiar, not familiar, but similar to the problems we've done in the past. By past, I mean the previous videos. I want to get my variable alone, so I would have to get that term by itself first. So I would subtract 45. Subtract 45, my 45s cancel out. I'd be left with negative 28 equals a negative 16t squared. I would then have to divide both sides of my equation by negative 16. Divide by negative 16. And that would leave me with t squared equals a positive 28 sixteenths. I would then take the square root of both sides. My squared and my square root would cancel out, and that leaves me with t equals the square root of 28 sixteenths, which is the same as the square root if I just reduce that to 7 fourths. And if you notice, when we did all these previous problems, I always had a positive or minus sign in front of that, say to be plus or minus, positive or negative. And this time we don't have to use that, because we know the ball was not in the air a negative amount of times. We know it was in the air a positive amount of time. So the square root of 7 fourths would be t equals 1.32 seconds. So using that vertical motion formula, we now know that if you drop a ping pong ball from a